Students, good evening to all of you. Today we will study the problem number 5 based on the empirical formula and molecular formula. Let's see the statement of the problem, students. See, there are the two parts in the problem. First, I am going to read the first part. Butyric acid contains only carbon, hydrogen, and oxygen. A 4.24 milligram sample of butyric acid is completely burnt. It gives 8.45 milligram of carbon dioxide and 3.46 milligram of water. What is the mass percentage of each element in the butyric acid? This is the first part completed, students. In the first part, we have to find out the mass percentage of each element. In second part, the molecular mass of the butyric acid was determined by experiment to be 88U. What is the molecular formula? In second part, we have to find out the molecular formula. So let's see the solution of first part, then we will solve the second part. Here, first we will calculate the calculation of mass percentage of different elements. So students, first we will calculate the calculation of percentage of carbon can be calculated. Percentage of carbon can be calculated as, okay, see here in the question they given carbon dioxide. So mass of carbon dioxide is given. So we will use the comparison CO2. CO2 contains carbon. How much CO2 contains carbon? 44 gram of CO2. This is the molecular mass of the CO2. 44 gram of CO2 contains carbon equal to 12 gram. You can calculate. Okay, you can say that 44 gram of CO2 contains the 12 gram carbon, or you can say that 44 milligram contains the carbon equal to 12 milligram. Okay, 12 milligram. So you can say that in the question they are saying that it gives the 8.45 milligram of carbon dioxide. So when 4.24 milligram of sample of butyric acid is completely burned, it gives 8.45 milligram of carbon dioxide and 3.46 gram of the water. So out of the what the data we are getting means that here naturally in the 44 gram you can say that 44 gram of CO2 contains 12 gram of the carbon, or simply you can say that 44 milligram of the CO2 contains 12 milligram of the carbon. So this we will write in the language 44 milligram of CO2 contains carbon equal to 12 gram. Sorry, 12 milligram, not 12 gram. 12 milligram. Okay. 44 milligram contains 44 gram of CO2 contains carbon equal to 12 milligram. So 8.45 milligram 8.45 milligram of CO2 contains carbon equal to 12 into 8.45 and divided by 44 milligram. Okay, so this is that. Now we will calculate the percentage of carbon equal to the percentage of carbon equal to weight of carbon upon weight of compound into 100. Okay. So here simply they given weight. Simply they given weight of carbon we calculated 12 into 8.45 into 12 into 8.45 divided by 44. And what is the weight of the compound? Weight of the compound already is given the question 4.24 milligram into here it is multiplied by 100. After solving you will get here 12 into 8.45 divided by 44 into 4.24 into 100. So this data will get, after solving this you will get 54.3%. So this is the percentage of carbon, 54.3%. This is the percentage of carbon. You can see how I solve this portion. You can check out. Okay. Here you can write 12 into 8.45 upon 44 upon 4.24 upon 1 you can write and into 100. Okay. So what will happen here? Numerator will be remain the fixed 12 into 8.45 upon 44, but denominator will be reverse 1 upon 4.24 into 100. So this came like this. So after solving you will get, that is the, here I applied one formula that if A by B upon C by D, then numerator will remain the fix A by B, denominator will be reverse D by C. That formula is applied here. So after solving you got the here 12 into 8.45 divided by 44 into 4.24 into 100. By solving you will get, that is 54.3%. This is the percentage of carbon. You can write carbon equal to 54.3%. Okay. See, percentage of the hydrogen can be calculated as, you can see it gives, when butyric acid is burnt it gives carbon dioxide and water. So water having the hydrogen equal to how much hydrogen is there in water? Water molecular mass of hydrogen is 18 gram, and water is out of the 18 gram, how much hydrogen present? 2 gram. How much hydrogen present? 2 gram. Okay. So simply here 2 hydrogen atoms present in water molecule. Okay. So you can say that 18 gram of, in 18 gram of water 2 gram of hydrogen is present, or simply you can say that 18 milligram of water, 18 milligram of water, 2 milligram of hydrogen present. Okay. Now we will transfer this expression in the language form. 18 milligram of water contains hydrogen equal to 2 milligram, 2 milligram. Okay. Now in the question they given, that is the 3.46 milligram of water contains. Now 3.46 milligram of water contains hydrogen equal to 2 into 3.46 divided by simply 18 milligram. Why we are converting everything in milligram? Because they are saying in the question, when 4.24 gram of butyric acid is going to 4.24 milligram of butyric acid is going to burn, then it is going to produce simply 8.45 milligram of carbon and 3.46 milligram of water. So we will find out, that is the amount of hydrogen and carbon. Okay. Already we find out the 2 into 3.46 divided by 18. This is the mass of the hydrogen. Now we will calculate the percentage of hydrogen. Percentage of hydrogen equal to, weight of hydrogen, weight of hydrogen upon weight of compound, weight of compound, weight of compound into 100. Okay. Now you can see weight of the hydrogen. Weight of the hydrogen is simply 2 into 3.46 upon 18 upon, this is the weight of the compound. Simply what is the weight of the compound? 4.24 into 100. So again we will solve here. We can write this 2 into 3.46 upon 18. Okay, like this. You can write this expression as the, you can write this expression 4.24 upon 1 into 100. Okay, by solving you can reverse this. Okay, you apply here one formula already I explained, a by b upon c by d. Numerator will remain the same, but denominator we revert d by c. So here you have to apply, that is 2 into 3.46 upon 18 into 1 by 4.24 into 100. So after solving, you will get the percentage of hydrogen. How much hydrogen you will get? That is 9.0%. Okay, 9.0%. So here we'll calculate the mass of oxygen is also there. So first we will calculate the total mass of, total sum of, total mass of simply can write in the language like this, the sum of percentage of carbon and hydrogen equal to, so carbon is 54.3 plus here 9% is the of the hydrogen. This is the percentage of hydrogen. By adding you will get 63.3%. Okay, already I solved, students. So now we will calculate the percentage of oxygen. Percentage of oxygen equal to 100 minus sum of carbon and hydrogen. So 100 minus 63.3 equal to the, it will comes at 36.7%. So this is the percentage of oxygen, and here we got the percentage of carbon. So in this A point we are able to find out the mass percentage of the carbon. We got already 54.3 and hydrogen 9% and oxygen 36.7%. Now we will solve the second part. Now for the solution of the second part, that is the calculation of molecular formula, we will write the elements. How many elements are there? Carbon, hydrogen and oxygen. What is the percentage? Already we calculated. Oxygen 36.7, hydrogen 9% and carbon 54.3%. Already we find it. Okay, what is the atomic mass? Atomic mass of carbon is 12 gram and hydrogen 1 and oxygen 16 gram. Okay. Now after this we will find out the moles. What is the formula of moles? Mass upon atomic mass. So mass, what is the percentage? This percentage will serve as the mass of the carbon. So 54.3, this is the mass of the carbon divided by atomic mass, you will get the moles. Now mass of the hydrogen is 9.0 divided by atomic mass equal to 9.0, and this is the 36.7 divided by 16, you will get the moles. So already I divided, that is it will comes 4.52%, 52 moles, 4.52 52 moles, and this will come 2.29 moles. Okay, now we will find out the mole ratio. So out of all these number of moles, we will see which is the smaller value of mole. So you can see 2.29 is the very smaller value. So we will divide all the moles by this value for getting mole ratio. So 4.52 divided by 2.29, we will get, that is 1.97, and 9.0 divided by 2.29, that is equal to the 3.90. It will come to 3.90, and 2.29 is divided by 2.29, you will get the 1. If you round off these numbers in the round off these number, this is equal to the 2, okay, and this is equal to the 4, and this is equal to the 1. So by using this table, we are able to find out the empirical formula. Empirical formula equal to, how many carbons are there? 2. C2. How many hydrogens we get? 4. C4. And how many oxygen? O. So this is the empirical formula of this question. Now by using this formula, we will calculate the molecular formula. So first we will calculate empirical formula mass. How many carbons are there? 2 carbon plus 4 hydrogen and plus 1 oxygen. 2 carbon, 1 carbon atomic mass 12, plus 4 hydrogen, 1 is 1, plus how many oxygen? 1, 16. So it will come 24 plus 4 plus 16. It will comes 28 plus 16 equal to 44 U. How much? 44 U. So up to this we are able to find out. Now what is the relationship between equal to molecular formula? Molecular formula equal to N into empirical formula. So here N into empirical formula. So first we have to find out the N. N equal to molecular mass upon empirical formula mass. So molecular mass is already given in the question, 88 U, and molecular mass, this is the molecular mass already given in the question, and empirical formula mass we calculated 44 U. So we'll divide 44 U. N equal to we'll get 2. So from here we'll get N equal to 2. We'll put the value of N equal to 2 here, and empirical formula we got, that is C2H4O. So molecular formula equal to C4H8O2. This is the student's answer. This is the C4H8O2. This is the molecular formula. Hope you got the concept. Thank you. Have a good day.